Alright guys, so today we're going to look at a specific kind of sequence. So if you look at these first two examples, we're going to look at some similarities. So the first one, you can tell every single time it's increasing by 3. And the second one, in every single term, it's increasing by 4. So since both of these are increasing by a constant number, or if they were to be decreasing by a constant number, these are what we call arithmetic sequences. Okay, so if there's a constant number that they increase by or decrease by each time. So what we can get with these kind of sequences, and because they are constant, we can actually come up with a formula for how we can write that sequence. And that formula is given down here at the bottom. And we're just going to talk about what each of those variables is. So a sub n, we've already talked about that. That just means my nth term. So if I'm trying to write a sequence for the nth term, then that's what I would use. If I want to find the 20th term, then that number would actually physically be the 20th term. Okay, the other numbers that I have here, I've got a. A stands for the first term. D stands for the common difference. And then N, which stands for the term number. And again, if we're trying to find the nth term, that will just stay as N. But if I was trying to find the 13th term, I would actually plug in the number 13 for N. So what we can do is we can use that formula to help us actually write some sequences. So if you look at that first example up there, we're actually going to find an equation for the nth term. So I'm going to take that formula where a sub n equals a, which is my first term, plus my common difference, which is d, times n minus 1. Now you can leave it like that, or if you were to multiply this out, you would get what you are used to solving this to be, which is 3n minus 1. Both of those are okay. What you can also use this formula for is, let's say I want to take that second equation and I wanted to find the 10th term. So what I could do there is use that same equation, but I want to find the 10th term. So I'm still going to plug in my a. The a on the second equation is 4. I'm still going to plug in my d on the second equation, that's also 4. And then since I'm finding the 10th term, I'm going to plug in 10 for n. So that gives me 4 plus 36, which is 40. So that is my 10th term of that equation. Alright, let's look at one more example. Now look, if you look, this sequence is actually decreasing. So I'm going from 7 to 5 to negative 3. But I'm going to set this up the same way, where my nth term is going to be my a, which is 7, plus my common difference. Now my common difference here is what I have to add each time, and since it's decreasing by 2, my d is going to be a negative 2. And that's how I'd write my sequence. Alright, so the last two formulas we have are actually not for the sequence, those are for our summations. And there's two different formulas you can use. They will both work, it's just a matter of which one's going to be easier based on the information that you're given. So the first formula on the left, anytime you see that s with that little sub n, that is the sum of some number of terms. So if you were to add up the first 5 terms, that n at the bottom would be 5. And if the number of terms you're adding is what takes the place of n. A is still your first term, and then a sub n stands for the nth term. So if you're finding the sum of 5 numbers, then a sub n is the 5th term. Then the second equation, all those numbers, again, same idea. N is the number of terms that you're adding. A is your first term and D is your common difference, just like it has been. And N is in two different places, but it still means the same thing. So what we're going to do is we're going to use both of those formulas to show the sum of the first 30 odd numbers. Okay, so my first 30 odd numbers, that's going to be like 1 plus 3 plus 5, and it's going to keep going. So we're going to use the second equation first because it's a little bit simpler with the information I'm given. So N in this case, I'm trying to find the sum of 30 numbers, so the S of 30. N in this case, since I'm finding 30 numbers, N has to be 30. Then it's 2 times my first term, which is 1, plus my common difference, which in this case, what I'm adding each time is 2, times N, the number of terms, which we just said was 30, minus 1. So when I break this down and do this math, I'm doing 15 times 2 plus 2 times 29, and I'll end up getting a sum of 900. Okay, I also could have used that second equation. The only thing that's different about the second equation is I don't quite have all the information yet. So in the second equation, what I do not have yet is that a sub n, that nth term. So I need to find that first. So I need to find the last term, which means I need to find the 30th term. So since I'm doing a of 30, I'm actually finding the 30th term, not the sum. I'm not going to use either of those two formulas. I'm going to use the first formula that we learned about the sequence, where I'm going to do a, which is my first term, plus my common difference, times n, which we said was 30, minus 1. And this is going to give us the actual 30th term. So my 30th term here is going to be 1 plus 2 times 29, which gives me a term of 59. So now I know my last term. So since I know my last term, I can just plug it in for a sub n into that last formula. So if I use that formula there, the sum of my first 30 terms is going to be the number of terms, which is 30, times the first term plus the last term divided by divided by 2. And if you think about it, guys, this formula actually makes the most sense, because if I'm doing 1 plus 59 divided by 2, that's helping me find the middle number. And if I'm increasing by the same amount up and down, if I just multiply that median by the number of terms, it's going to give me the sum, which in both cases is going to be 900. All right, so that's just a few of our arithmetic sequence formulas. We're going to look at a different kind of sequence coming up later.